Okay, so now we're going to take a look at some equations using natural logarithms or e as a base. Now, we've solved the logarithmic and exponential equations in prior lessons, and so all of the same situations can occur. You need to check for extraneous solutions. You need to maybe convert back and forth depending on what's given or whatever strategy that you're using to solve these. Except now we have one additional fact. We need to keep in mind that log base e is the same thing as the natural log. So sometimes if we need a base for our logarithm so that we can convert it to exponential function, we need to maybe remember that we're using a log base e. So work the sample problems if you haven't yet, and then take a look at the solutions. Alright, so if we look at part A, we have the natural log here. And so I need to convert that. I have a logarithm on one side, not the other. And so I really need to convert that to exponential to make it an easier equation to solve. So the easiest way for me to do that is to just rewrite this back in terms of log base e. And now what I can do is I can use that little circular trick that we've been using to rewrite this. And so I'm going to have e to the fourth power equals x minus 3 squared. Now from here you might be tempted to take the fourth root to actually get e by itself, but at this point that's gonna leave us some difficulty on the right side of the equation. A better strategy is actually to take the square root of both sides. In doing so, I cancel out on the right side, I cancel out the square. On the left side, remember, if we take the square root of e to the fourth, this is actually going to leave us a plus or minus e squared. And now I can just add 3 to both sides. Now, that being the case, e squared is an actual number. You can punch that number into your calculator, and you can either add it to 3 or you can subtract that from the given 3 value. So we need to go ahead and come up with those two approximate values. And you get roughly these values right here when you do that. Now, if we take a look at this, and it says x is a negative 4.3891, if you were to plug that back in, you would see that that value would actually be extraneous and could not work. So this value, and I would not plug it in as a decimal. If you want to go back and plug in the actual values, what I would do is I would actually plug in for x the exact values to see if it gives you a true or false statement. And so what you'll see is that this is actually extraneous solution. Alright, so moving down to part B, let's take a look at that. Now here we have an exponential equation with the exponent only on one side, so we're going to isolate that first. And it's best to go ahead and reduce the fraction. Now we have a base on the exponent of e, so I need to convert this to a log. And of course, if I just did that according to my little rules here, I'm going to end up with log with the base e. And of course, we know that's the natural log, and so you can write that as the natural logarithm. And I just went ahead and converted that 7/2 to a decimal just because it's a little easier to work with. And then x is going to be the natural log of 3.5 divided by 2. And again, if you just punch that in your calculator, you can get an approximate value. And you can take it out as many decimal places as you need to. Again, if you want to check this, it would be best off to check it with the exact value for x to see if it works out for you and doesn't give you an extraneous solution. Alright, so we'll stop right there and we'll take a look at the last couple sample problems in the next video.